Welcome to the lesson on the mode of grouped data. At the end of this lesson, you will be able to define the mode of grouped data. You'll also be able to calculate mode of grouped data. Miss Greenfinger's heart beats for the trees. She recently conducted a tree plantation program in 60 schools of her city. Now, why is she looking so hassled? Actually, Miss Greenfingers is preparing a project report. She has to find the maximum number of trees planted across all 60 schools. Now, what does this mean? Look at this example. The data for 6 schools is given here. Which value representing the number of trees planted is repeated frequently? Note that 6 trees are planted in one school, 2 trees are planted in 2 schools, and 4 trees are planted in 3 schools. In this case, 4 is occurring the maximum number of times. Now, coming back to Miss Greenfinger's data, let's help her find the maximum number of trees planted across all 60 schools. She has the grouped data of all 60 schools that participated in the tree plantation program. Observe the data presented in the grouped frequency distribution table. To find the maximum number of trees planted across the 60 schools, Miss Greenfingers has to find the mode of this grouped data. Recall that the mode of a given set of data is the observation with the maximum frequency. Now, let us find the solution to Miss Greenfinger's problem. The table represents the class interval of the grouped data and the frequency for each class interval. The first step towards finding the mode of the grouped data is to locate the class interval with the maximum frequency. In the given data, the maximum frequency is 20. The class interval corresponding to the maximum frequency is called the modal class. Here the modal class is 65 to 85 as it corresponds to the maximum frequency of 20. The mode of this data is calculated using the formula shown here. Now, let us find what each term in this formula represents. In the formula for mode, L stands for the lower class limit of the modal class. In this case, the value of L is 65, which is the lower class limit of the modal class 65 to 85. The H stands for the class size. While finding the value of H, we assume that all class intervals have the same class size as in the case of this table. Here the value of H is 20. Next, in the formula, F1 stands for the frequency of the modal class. In this case, the modal class is 65 to 85 and its frequency F1 is 20. Moving on in the formula for mode, F0 stands for the frequency of the class preceding or just before the modal class. In this case, the class preceding the modal class is 45 to 65 and its frequency F0 is 14. Finally, in the formula for mode, F2 stands for the frequency of the class succeeding or just after the modal class. In this case, the class after the modal class is 85 to 105 and its frequency F2 is 6. Now, let's substitute the values of L, H, F1, F0 and F2 in the formula for calculating mode. Let's simplify this expression further. The mode of a given data is equal to 71. Miss Greenfinger's problem is solved. The mode or the same number of trees planted in maximum number of schools as per the given data is 71. You've reached the end of this section. Before moving on, let's review the key points covered in this section. The mode of a given set of data is the observation with the maximum frequency. The class interval corresponding to the maximum frequency is called the modal class. The formula to calculate the mode is as shown. Here, L stands for the lower class limit of the modal class. The H stands for the class size. F1 stands for the frequency of the modal class. F0 stands for the frequency of the class preceding or just before the modal class. F2 stands for the frequency of the class succeeding or just after the modal class.